last time we got our player character moving around the world, and we learned how to do raycasting and jumping, and update versus fixed update. And this time we are now going to get into how do we manage the logic between scenes. So in this class, regardless of whether you're making a 2D platformer or you're making a 3D game, for your final project, you're orchestrating your game across multiple scenes, which usually means that you're going to have to store information and refer to it across multiple scenes. So for instance, here I've got a demo. This is what we'll build today, where we're tracking the score of the player, and we can collect some fruit from the first level, increase our score, and the score is persistent, so we can add some more here, and then we can go to a final scene that has like a summary. And so in each scene, we are able to track that score and keep it persistent across the whole game. So this same idea would apply if you have like an inventory system and your player goes to different scenes where they're like collecting things and then using them in another scene. So inventory lives, like anything in your game that has to persist across scenes. You'll have to figure out a way to do it, because so far what we've seen in Unity is that when you create a scene and put these objects in it, none of them come over to the next scene by default. So we're going to learn how to do that. I'll show you a technique for persisting game objects across scenes, and probably along the way we'll implement these collectibles, and we'll learn how to do this camera tracking in 2D using Cinema Sheen, which is really powerful and applies to both 2D and 3D games. So what I'm going to do is I'm going to pause the video. I'm going to rip out a bunch of things from this project so that we can start with something clean, and we'll go from there. All right, so I ripped out most of everything from that solution to give you something that's close to what we started with last time. So some of the changes from last time, I have an apple prefab, but I also sliced up the banana, added the animation to it so that I can drop bananas in the second level, so that we can have a different collectible in each level. Also, I sliced up in Pixel Adventure the under items checkpoint the flag so that we can drop this in. So if you want to follow along, go ahead and slice those up and generate the animations ahead of time. But if you don't want to do that, you can just grab placeholder things. So you can use the apple that we worked on last time, and then you can just grab any other sprite to use as the checkpoint. So the structure that I have set up here, I have level 1, which is kind of a basic platforming level. We're gonna teach the player how to jump in a really safe environment. There'll be the transition, the goal over on the right hand side that takes them to the next level, where they will have to jump in a more dangerous setting. So jump from here to here to here to here to the get to the goal that takes you to the final screen. And this final screen, just so that we don't have to set it up together, I have set up some user interface that displays game over text, and then there's a text box for displaying the score. And the font that I'm using here is from Kenny, so I will have this linked in the canvas, but if you Google search Kenny fonts or you go to this URL, you can grab this cool CC0 pack that you can use in your games of different fonts. So this one fits nicely with Pixel Frog's aesthetic. So we're going to run with that. So the first thing that I think I want to do is set up Cinema Sheen. So right now, if we play the game, we have our character that can move around. We haven't made these things collectible yet. We don't have our level transition, but it would be really nice if the camera actually followed the player, because as soon as we get to the second level, we are going to have a level that's bigger than the camera, and we kind of need the camera to follow the player for them to actually navigate through here. So Cinema Sheen, this will be real basic, and I will link to a tutorial that goes a little bit slower through this. But the idea with Cinema Sheen is that you're going to have a virtual camera that takes control of your main camera. And that virtual camera can be told to follow a target, look at a target. It works in both 2D and 3D, and so it's really powerful. And the reason why it uses virtual cameras is then it makes it really easy to switch between multiple virtual cameras. So if you're composing a 3D scene and you want to be looking at the player, and then when they trigger something, like cut over to another camera that's looking at a door that opens. Cinema Sheen is great for that. So to use Cinema Sheen, we're going to have to open up the package manager, which has some Unity packages loaded in it that have been produced. And so Cinema Sheen is in here. If you give it a second to load, what you want to do is click install. And this is going to take a second, so I'm going to pause the video and come back when it's done. Okay, so when it finishes importing, it's going to bring a new tab at the top here that gives you easy ways to create different types of cameras. So there's a basic virtual camera, there are some different flavors of cameras, and for us, we want to create the 2D camera. So as soon as we select that, that drops a virtual camera in our scene, and you can see our view has actually changed. So this virtual camera is driving the settings on the main camera. So if I change this orthographic size to 10, that has now changed the orthographic size on our camera. So now we want to use the settings here to configure our camera as opposed to using the settings on the main camera. So you might want to find like a good zoom by changing the orthographic size. And what we want to do is set this up to follow our player. So I'm going to drag my player to the follow and drag my player to the look at. And already what that's going to do is be set up to have a camera that will follow the player as we move around. And what you're seeing here is a visualization of the settings of the camera. So I'm not going to go super in depth on these settings. The videos that I'll link will explain these. But basically, you have a few things. You can dampen the camera so you can control how quickly it follows in the X and Y. So you can see how quickly it's following the target here versus when we had it dampened at 1. There's a little bit more of a smoothness to the camera motion. So I recommend using some amount of dampening on your camera. The screen X and Y allow you to shift up or down the camera from your target. So I'm going to leave them at 0.5, 0.5. And then the dead zone width and height, you can see these lines that are being configured around the player. With the dead zone, you're essentially configuring an area where the player can move around without the camera following them. So if you don't want the camera to be jittering with every movement of the player, or you want the camera to stay stable when the player is jumping, you can configure your dead zone so that the camera's only going to move when the player moves out of that dead zone. So I'm going to leave play mode, and I'm going to configure a little bit of a dead zone here. Let's do 0.3, 0.3, see how that feels. Yeah, that's okay. So this will be fine for what we're doing. Actually, maybe I'll shrink the dead zone width slightly. But we'll maybe come back and tweak these and use the look ahead settings. All of these are explained in the video, so go check them out. This is a really useful thing. I'm showing it for 2D, but it's also going to apply to 3D and give you smooth motion in your 3D games. So now that we have this rig here where we have the player, the camera, the virtual camera, what I want to do is make sure that I bring those over to my level 2, because in this version, I just have a ground and a background tile map, and I actually don't have the player in here. So when you're making your second level, you can duplicate your first scene to copy those objects over, but what you probably would rather do is set up a prefab that has all of this configured so that it's really easy to keep your settings synced. Like if we go ahead and change the player in this scene after we've duplicated our scene to create level 2, those changes will only apply to the player that's in the first scene. And if you want to have a live link, we got to create a prefab. So what I'm going to do is create an empty game object, put it at 0, 0, 0, and I'm going to call this the player. Let's call it the 2D player rig. I'm going to drag my player, the main camera, and the virtual camera from Cinema Sheen, and this is going to be my prefab. So if I drag it into prefabs here, I should be able to save this, go to level 2, drag in my rig, and place the player. So let's grab the player and move the player over this platform here. And if fingers crossed, everything worked. That means that now I have a camera that can follow around the player as they're exploring the second level. So as we're building this out, we're going to want to be mindful of basically anything that we're sharing across scenes. We're going to want to turn into a prefab so that we can have easy ways to edit those objects and have those changes apply across all of the scenes. So let's set up an object that actually allows us to travel from level 1 to level 2. So inside of the assets here, I have already sliced up this checkpoint. And let's see, do I still have the animation? No, I deleted it. So we're going to make that. So what I'm going to do is drag one of these checkpoint frames into the scene. I'm going to just call it checkpoint. And I'm going to bring it over here and move it to the foreground. Place it somewhere around here. And then I'm going to open up the animation window and do what we did last time and use these frames in an animation clip. So I'm going to call this animation, the checkpoint animation, drag these in, change the samples to 20, make sure that it works by playing it, good. And then what we can do is turn this checkpoint into a prefab. So I'm going to drag it over here, which means that now I've got an object that if I make some changes to this prefab, I can drop it into both scene 1 and scene 2 and have it work. So I'm going to drop one prefab into scene 2 while we're at it. Okay, so we've got this checkpoint, and what we need it to do is detect when the player collides with it. And when it does, we'll use the scene manager to say, now it's time to go to the next level. So anytime you're switching scenes, you want to make sure that in your build settings, you have added all of the scenes that are going to be a part of your game. So right now I don't have any in my build, so I'm going to drag all of these over. So I'm going to have level 1, level 2, and windscreen in my build settings, which means that I can now use level 1 and level 2 and windscreen with the scene manager to say, go to that scene. So let's edit this prefab. So I'm going to double click this to go into edit mode for the prefab, which means that now any changes I make here will be applied to any instances of that prefab across my scenes. If we want to detect that the player can collide with this, or when we want to detect when the player collides with this, we need to add a collider. So I'm going to add a box collider 2D here, and oh, whoops, don't do that. So I'm going to remove this. What I'm editing when I've clicked over here is actually the prefab, which doesn't have full editing support. So when you double click on it and it opens up here, make sure that you have the thing in your hierarchy selected. So now I'm going to add the box collider 2D here. I'm going to edit the collider to bring this in. Let's do something like this. That should be good. So I can then leave the prefab editing mode, and if I inspect this guy, now he has a box collider 2D here, which should be all set up. So now we just have to do some scripting, and this is scripting that we've done before when we were changing scenes based on creating a main menu. So I'm gonna go into my scripts folder, create a new script, and let's call it trigger to next scene. So when we are creating something that uses the scene manager, we want to bring in that namespace. So it's unityengine.scenemanagement. And now we'll be able to access the scene manager. So let's do Ontriggerenter 2D. So there's a 2D version of all of the 3D things that we've learned. So Ontriggerenter 2D is the one that we want to use here for the 2D physics engine instead of Ontriggerenter. Here we can call the scene manager .load scene, and we can pass in the build index from the build settings or the string. And so if we were just to write this script so that it would take us from level 1 to level 2, this would work fine. But we need this to be a field so that we can configure our prefab to take us to different scenes. So from level 1, it should take us to level 2. From level 2, it should take us to win scene. So what we want to do here is create a serialized field, and it's a private string called, let's say, next scene name, and use that instead here. So the reason why I'm using Ontriggerenter is that inside of a scene, when you have a collectible, you don't really want the player, or a collectible or something like this that is just a trigger, you don't want the player really to like, let's see what happens when we walk over to it. There we go. So we don't want the player to actually like physically interact with this object at all. We just want to be able to detect when the player is over this spot. So that's why I'm going to use a trigger here. I'm going to make sure that I'm editing my prefab. So my checkpoint here, I'm going to open up the prefab and make sure, nope, I forgot to do it. So I'm going to make sure that this is a trigger now. So the player will be able to walk through it. And I'm going to grab this and drop it onto the prefab. So I'm going to open up the prefab again, drag trigger to next scene in here, and we can go back to our scene. And now for each scene, we want to go to the checkpoint and fill in the specific scene that we want to transition to. So I'm going to say level 2 here, save it, and then I want to go into my level 2 scene where I've got this one set up. And you can see how when we were editing the prefab, this made all of those changes, so it now is a trigger, and we can set this to go to windscreen. So I'm going to go to level 1. Let's see if this works. Nice. Okay, we're in level 2. Perfect. Okay, so we've got our camera following out of the way, and we have our transition that allows us to move from scene to scene. So now we're really getting to the meat of what I want to do with this demo, which is track the score. So we want to have the player's score somewhere on the screen, and then we want that score to go up every time we pick up one of these collectibles. And we want that to happen both in scene 1 and scene 2, and then display the final score here at the at the last scene, the windscreen scene. So in order to do that, we need to do a couple of things before we can actually get into score. We need to make sure that these things that we have in the world, so I have them under organized under empty game object, the apples. These should be collectibles. So we need to do a similar thing that we did with the flag. Ontriggerenter, when we touch one of these apples, we should increment the score and we should remove that apple. In order for that to happen, we need to add a collider, we need to add a script, and we need to have some way to know when the player has touched one of these things, and we're going to use tags to do that. So let's edit our apple prefab. So I'm going to open that prefab. We don't really want to use a box collider, so let's use a circle collider. This will be a better fit for this sprite. I'm going to hold Alt. Oops. Do that again. Grab this, and I'm going to hold Alt to scale it down symmetrically. That looks decent. Maybe I'll offset it a little bit vertically. In general, when you're doing your collision detection, when it is something that is a trap or something harmful to the player, it's usually kind to shrink that down slightly. And then for like positive things like these collectibles, it's okay that like this collider doesn't match exactly, and maybe we can make it slightly bigger. So it's easier for the player to get the positive things. So there we go. So this is a collider. I want to make sure that it's a trigger. Save this, and I'm going to go into my banana prefab, open this up, and do the same thing. Okay, that looks good. So the other thing that we need to do with these is set up a tag. So when the player collides with the apple or with a banana or anything else in our game that we want to say is a collectible that should increase your score, we want to have a tag that allows us to identify that. So we can go into our apple and add a tag here. I'm going to call it collectible. Save it, and now that I have added that tag, I can go back to the apple prefab, tag it as collectible. I can go to the banana one, tag it as collectible. So now all of my apples in scene 1 and in scene 2 should be tagged as collectible, which means that we can start thinking about that script. So I'm going to create a new script here and call it collect fruit. And let's put this script onto our player inside of our player rig. So I'm going to open up that prefab, go to the player, and drop the collect fruit here. And then open this up. So we're going to want to use Ontriggerenter 2D. And because this could be triggered when the player touches an apple, a banana, or the flag, we want to set this up so that it only filters for those tags. So this collision object, we can say if collision.compare tag collectible. This will only trigger when we are sure that we have hit a collectible, something that we've tagged as collectible. So here, this would be our to-do, increase score here, and then let's destroy collision.gameObject. So this is destroying the thing that we have just collided with. And while we're at it, why don't we improve this a little bit? We learned how to use the attributes last time, so we could say that this component require component type of collider 2D. So we're basically saying if we put this on anything in our game world, we want that thing to have a collider 2D so that it can actually have an Ontriggerenter. Because if there's no collider, there's nothing for the player to actually use to hit a trigger. So let's see if this works. Save it, flip back to Unity, go back to our scene, give it a shot. Boom, boom, boom. And it should work for our bananas. Whoop. I forgot to edit my banana bunch and make it a trigger. So let's try that one more time. All right, we got these three. There we go. We should be able to get the banana. So now all we have to do is figure out how we can track the score and keep that score going up every time you hit one of those. So the problem that we're going to run into is that if we have the score somewhere in our scene, let's say our player, we add a script to the player, it's keeping track of the score, it's an integer, we increase it every time the player hits one of these things. As soon as we go to level 2, we've lost that player and that instance of our mono behavior that had the score attached to it. And now we have a new instance. So all of this stuff, even though it's linked via prefabs, it's not going to track the live data from level 1 into level 2. Instead, what it's going to do is just give us a fresh copy. So our score would reset here. So we're going to build out our score manager, knowing that that's going to be a bug that we're going to encounter, and then we're going to work around it and figure out a way to make objects persist across scenes. So I'm going to go back to level 1. And when we're thinking about managing a piece of information like the score, there's often multiple parts that we can split across scripts. So we can have a single script that is responsible for managing the score. It just holds on to that data. It has an integer for the score. Maybe it has a method to track this, to increment the score. That's one script. The other script might be responsible for displaying the score in some user interface. And so we can then figure out ways to hook up those two scripts together so that they are separate, but that the display script can actually reach in and read the score manager's individual score value at any moment in time. So let's do that. We're going to create a score manager. Whoops. That's not spelled right. Let's try that again. Score manager. And while we're at it, let's create a script for displaying the score. Score display. And the reason why we separate these out is because this score display is going to put the score in the bottom left-hand corner here. And it's going to use Unity's text elements. But it's useful to separate out the the data from the display, because maybe in the future you're going to have to refactor it and use another GUI kit for displaying the score. Or in our case, we're probably going to have score that gets displayed here and also in the level, and we might need to display it differently in those places. So we don't want all of that logic to be in our score manager. We kind of want to separate those out. So let's open our score manager here and get started with a script. So I'm going to clear out all this. Let's create a public int score. So what I'm doing here is creating a property called score, which has a getter and a setter. This score is public, which means that other scripts will be able to access it, but no one will be able to set it directly, which means that we can have other things that can read the score and display it, but nothing is going to be able to mutate the score directly. And then since nothing can mutate it directly, we want to make sure that we have a public method, increment score here, which let's say you pass in the increment. This is the method that is responsible for increasing our score. And we're going to have a default parameter of 1. So if someone calls this without passing anything in, it'll just increase the score by 1. But we want to leave this open so that we can have a parameter. So maybe like the apples are worth 1 and the bananas are worth 3, and then there's another one that's worth 10. By making this increment a parameter, we'll be able to factor that in. So we've got our score manager here. And let's go ahead and add this to our scene. So I'm going to create an empty game object, score manager, and I'm going to attach our score manager script and then turn this into a prefab while we're at it. So we've got our score manager. Let's add our score display. So what we're going to need is UI text, which is going to give us a canvas, some text, and the event system that's responsible for making sure that the canvas can respond to input. So this text, let's rename this the score text. Put some placeholder text in here of score 0. I'm gonna use that font that I pulled, which is Kenny Mini Square. I'm gonna make this white. Let's scale up the font size a bit. And as soon as I scale it, it is now clipping out of our box, so it's not being rendered. So I'm just going to hit F here to focus on the canvas. I'm going to grab my score text, make sure that I've got the rect tool selected, and scale this box up a little bit so that the score doesn't clip and get truncated. Let's go ahead and make sure it's left aligned, and let's align it to the bottom. And then I'm going to make sure that the anchors are set up so that this text shows up at the bottom left of the screen. And then maybe I'll shift it up a touch. And that should be good enough. So what we want to do here is have a script, this score display, that's attached to our score text here. So it's responsible for making sure that this text is always in line with whatever the score manager says the current score is. So what we can do here is open up this script, and we can clear out start and update. So there are a number of ways that we can make score display connect up to, let me switch back to Unity here, this score display script that's attached to our score text, that we can hook this up to the score manager. There are many ways to do it. One good way is with delegates, where you have an event system that basically the score text can subscribe to the score manager and be notified anytime that the score manager changes. For the sake of brevity, I want to really focus on the data transfer across scenes. We're going to do something that's a little bit hackier. Basically, we are going to get a reference to that score manager, we're going to get the score manager script, the component there, and inside of update, we are just going to constantly, every tick of the game engine, make sure that the text displays whatever is in the score manager. So I'm going to bring back the update method. We're going to need that. This is where we're going to set the score. We're going to need to create a serialized field that has access to our score text. And we're going to bring in the Unity engine.ui. So here, we're going to do score text equals, and we want to fill this value in with whatever comes from Score Manager, but let's make sure that this is working currently. So if we flip back to Unity, we should hopefully see that text change to 10. Make sure that we hook this up. So I'm grabbing the score text and dragging it in here to the score display. We could also use get component from score display to get this text, but this will be fine using a serialized field. So now we should hopefully see, yeah, there we go. So this is hooked up. It can update the score from the score manager, but we need to get a reference to that score manager script. So we can't use get component here, and we're not going to be able to use a serialized field because we are going to be setting things up so that this text and this score manager aren't always in the scene at the get-go when the scene loads. We're going to make sure that this score manager stays alive and travels from scene to scene as we transition from scene to scene, which means that we're going to have to do a dynamic lookup. So this score display is going to have to ask the scene for this score manager object, and then ask that for the score manager component. So let's do that. We are going to create a field here for the score manager. Let's bring back start. So this is a place where we can cache that score manager lookup so that we don't have to constantly look it up every update. What we can do here is get the game object. So this is going to be that score manager object in our scene using gameObject.find. And we are going to put in score manager exactly as we typed it for our game object. So that is with a space. And then we can use get component to say, here's our score manager game object. Give me that script, the score manager. And because we made the score a field that is public or has a public getter, we can say .score here. And so now this script is going to look up our score manager once when the scene loads. And then every update is going to go ahead and make sure that the text in our UI matches whatever the score manager says it is. So if we want to kind of test this out, what we could do is set score equal to something like 20 here. Cross our fingers, hope that I didn't make any typos, and 20 shows up here. So we've now hooked things up so that if we were to change the score when we hit one of these collectibles, we should have the UI update as well. So let's go back here. Let's initialize this to 0. Actually, let's put this in start. Instead of using an initializer up here. Okay, so we've got our score initialized to 0. We have a method to increment it. So now what we need to do is, really similar logic here. When we go to hit something in this collect fruit script, we need to increment the score here. So we're going to do the same thing. Collect fruit, this is attached to our player. And on start, we want to do this lookup that we did here. So I'm just going to grab this, copy and paste it over to collect fruit, and grab our score manager field. And then down here, when we hit a collectible, we can say score manager dot increment score and pass in whatever value we want to use. In this case, let's just say everything is worth 1 point, 1 unit of score. So we're going to increment by 1. Let's flip back. Whoops, forgot a semicolon. Or I have an extra semicolon, so there can't be a semicolon at the end of a property. All right, let's run it and watch our score hopefully go up. 1, 2, 3. Okay, so now let's watch what happens. Actually, let's do this. We've got our score manager as a prefab. Let's go ahead and make this collection of user interface stuff a prefab so that we can bring it over to the other scene and we can see that problem that I was mentioning, that if we put the same object in multiple scenes, it's a fresh version. So our score would be reinitialized. So I'm going to call this game UI. Put it at 0, 0, 0. I'm going to grab my canvas and my event system. I am going to drag this in as a prefab. So I'm just making it so that it's really easy for me to bring this user interface over to my second scene. So hop over to scene 2, drop in my game UI. I could also drop in the score manager here. Okay, now let's try that again. So we're in scene 1, everything's working, we're collecting the score. I go to scene 2, my score goes back to 0. And that's because we have a fresh version of our score manager and basically everything in our scene. So let's go to level 1 and let's start fixing that. So I'm going to pull up the docs. Let's look for don't destroy on load. So don't destroy on load, when we pass in an object, will tell Unity that that is an object that should persist from scene to scene when we switch scenes. So we want to call this and pass in our score manager game object to make sure that that score manager doesn't get reinstantiated in each scene, that it's the same one, that it can have its persistent data. So let's flip back to Unity. What we want to do is go to our score manager. Inside of start, we can do don't destroy on load and pass in our game object. So game object refers to the game object that the script is attached to. So this is going to refer to, inside of Unity, this score manager game object. And as soon as we hit play, we're going to see that our display has changed. So we've got level 1, and then Unity has also pulled score manager out and put it into this don't destroy on load. Let's grab some points, head to the second one. You can see that our score, this is actually worked out okay, and the score is there, but we have 2 score managers. So we kind of got lucky that this actually worked with don't destroy on load. And really what you want to do is make sure that you don't have multiple score managers like this. Because if we have multiple and we do gameObject.find, we're only going to get one of them, and it's up to Unity to sort of like determine, however the algorithm works, which one is it going to give up to us. And if it gives us the wrong one, we'll have the wrong score here. So 2 ways to handle this. One, we could go into level 2 and we could just delete our score manager and make sure it's not there, and make sure that in every other level we don't have the score manager, which is a little bit of a pain, because that means that if we go to level 2 and we just want to like work on level 2, we'd have to add the score manager temporarily and then sort of like remove it when we build the game to make sure that we only have one. If that's one approach that's really simple, is just make sure your first level has all of those objects that you want to stick around. The other approach is to use a pattern called a singleton, which will make sure that we only have one of this instance. So basically the idea is, inside of this script, when we're doing this don't destroy on load, we want to check, are there any other score managers? If there are, destroy them so that we only have one that sticks around. There are a number of ways you could do this. You could here do a game object find and look for everything that's called score manager, or you could do a game object find by component and look for everything that has this score manager component. But we'll use the singleton pattern. It's something that you should think about using sparingly because it introduces some global variables, And there's some ways around that, but we're going to do a simple version of it. So the Singleton pattern usually has a static field that's public. It's of type score manager, and we'll call it instance. Actually, let's not make it a field. Let's make it a property. So this is saying that anyone can access this instance field that it points to an instance of our score manager class, and only from within the score manager class can you set this field, this property to be something else. So inside of start, what we can do is say if instance is null, don't destroy on load, and set the instance equal to this. So what that's doing is, when this is created for the first time, this is a reference type of variable, which means that by default it's going to be null. So we're checking, has this been filled in yet? No. Okay. Don't destroy this game object. And now this game object is our instance. It's the only one we want to keep around, which means that when the second score manager is created, we would actually be in this else statement. And what we can do is just say, immediately get rid of the game object. So let's go ahead and test this out and watch our hierarchy. Okay, so this first one, it ran. It was the only score manager because the instance was set to null. So this is now the one we want to keep around. So as we run through and go to the next scene, we can see that there's only one score manager here because the other one that was in our level 2, when the script ran a second time, the instance was already filled in, so it destroyed that other game manager. That's kind of the basics to Singleton pattern. I want to show you something a little bit more advanced that you can do using generics, because if you're doing this pattern in multiple places, it's a bit of a pain to have to add this logic to every manager that you want to turn into a singleton. So generics are a way to work around that, where we can define a singleton generic that has this logic in it, which will keep our score manager code a bit more simple, a bit more tidy. So what I'm going to do is flip back to Unity. Oops, flip back to this one. Let's leave play mode. I'm going to add a Singleton Script. Pop it open here. So the syntax for generic looks like this, where we can specify this is a class that has some type. It can accept a number of types. And we're going to restrict this, and we're going to say that the type has to be in the mono behavior tree. And then basically what you do is take the logic that we were doing inside of score manager here. So I'm just going to copy this over. Let's get rid of the score part. And actually, let's do this in awake as opposed to start. Awake happens before start. So when you're converting code that you have already to a generic, it's really those places where you were using a specific type, like score manager. We're going to replace T with T. So now this, whatever type is used in this generic, that's what type this instance is. And when we get down to here where we're running this logic, it's telling us that it can't convert from this type to this type. All we have to do is a cast here to tell the compiler that we know, yes, T is a mono behavior. It can be cast here as the instance. And let me add some notes so that this is a little bit more clear. Whoop. Come back to me, Visual Studio. All right, I'm going to pause the video while this finishes crashing. Okay, we're back. So the reason why we have a generic that inherits from mono behavior here, so generic that inherits from mono behavior ensures that we can use the Unity API. So that means that we can use destroy on load and destroy here because we are saying that this singleton inherits from mono behavior. And then we can add a note where T inherits from mono behavior. Where, we could technically say what this is doing is saying that either T is a mono behavior or it inherits from mono behavior. So where T is mono behavior or inherits from mono behavior, that ensures that we can actually cast from T to singleton T. Because we've said that singleton T is a mono behavior, T is also a mono behavior. They have a shared parent, so we have a guarantee that we can actually cast from T to singleton T. All right, we have genericized our code that had to do with making a singleton, which means that when we go back to our score manager, instead of having all of this specific code here that turns it into a singleton, we can just do singleton. Oh, whoops, not there. We want to do this here. Singleton mono behavior. And that logic is enough to create the single instance. We have taken this code, and when we say that score manager inherits from singleton mono behavior, that means that all of this logic gets filled in, so that it's essentially equivalent to what we did before. So we can run this, we can make sure it's still working. We only have one score manager, our score is going up. There we go. So we figured out how to keep objects around, and we figured out how to make sure that there's only one of that object around. So singletons often get a bad rap because they introduce a global variable. So we have this static public field called instance. The singleton pattern actually tries to do two things. It tries to make sure there is only one of this object, and it tries to make sure, and it also makes that object accessible publicly. So it's a global variable. And generally, global variables are bad. This pattern is one that you can sort of use sparingly in your game. Don't make everything into a singleton, but try and limit the number of times you use it to the essential things that need to be transferred from scene to scene. So the last thing that I want to show you, just kind of tack on, since as you're working on your final projects, you start thinking about level progression and how to create things that have some timing. I want to show you how to create, let's go to level 2. And we want to create something like a trap that kind of falls down. Maybe we'll put it over, let me zoom in here. Maybe we'll put like a trap over the second jump or the third jump here that kind of like has some saws that fall down. So let's see, we've got in Pixel Adventure, traps. Yes, under saw, we have this. So I'm gonna bring this to the foreground. This is huge. Maybe we'll scale it down to 0.5, 0.5, 0.5. And let's maybe, we can get rid of this collectible and put a trap in here instead. So what we kind of want to do is have a saw. So I'm going to rename this to saw. We want to have like some kind of spawner that like drops these in and drops them in at some interval. And we saw how to use set interval and a repeating interval previously in class. But there's another thing called a coroutine that allows us to essentially schedule things really easily, which will be generally useful. It's useful in this case where we want to have like a couple of saws dropping down with some kind of timing pattern, but is also more generally useful when you're working on your games and trying to sequence things. and create difficulty curves. So what I'm going to do is make sure that I have a saw that can fall down. So I want to make sure that it's got a circle collider on it, and I want to make sure that it's got a rigid body 2D and that it's dynamic. So when we hit play on this scene, we should see that saw fall down. Good. So I can now turn this saw into a prefab, delete it from the scene, and I don't want to create a saw directly. I want to have a spawner that spawns them in. So I'm going to create an empty game object in here inside of my level. Call this the trap spawner. And we are going to need to create a trap spawner script that goes along with this. Oops. So let's create trap spawner. So we don't need update, we just need start. And because we're spawning something, we're going to need to create a serialized field that has room for that game object. We'll call this, let's call it our saw prefab, or well, let's call it trap prefab to be consistent. And let's create a spawn method that just instantiates that trap prefab and uses wherever that game object, our trap spawner, is located. So we're going to say transform.position, and let's use the trap prefab's default rotation. So we're reaching into the prefab, we're going to the transform, we're asking for its rotation, and to keep our scene hierarchy nice and clean, we'll say that this trap prefab, the newly instantiated one, is a child of the trap spawner. So to make sure that this works, let's just temporarily put a spawn command inside of start. We will fill in this trap prefab, make sure that this is on our traps. This is on our trap spawner game object, so it should be in our scene. So trap spawner. Drag the script onto it, fill in this with our prefab. And then if I make sure that I've got some visual icon, I can see where my trap spawner is, and then I can move it around. So that's definitely not where I want it. Let's go ahead and move it here. And hit play and see that it spawns something and drops it. Cool, good. So we'll move it over this gap. Save it, and let's look at how we can make this happen over time. So we know that we can do the repeating interval, but if we want to create something where we can have like it spawn quickly, so maybe there's like a little bit of a delay between two saws, and then there's a greater delay. So it's like bump, bump, bump for the pattern of them spawning. So you can kind of create a spot for the player to sort of jump through. Using the repeating interval isn't as powerful as using coroutine. So we're going to do, I'll make sure that there's a longer tutorial that explains what enumerators and coroutines is. I just want to give you a high level preview. So enumerator, form, spawning. So this method is returning something called an enumerator. So it is a thing that can be enumerated, or counted, or looped over. And the basic idea is that we can create a function that can be paused. So we can do something like spawn, and then we can return or yield. Return new wait for seconds 0.5. Whoops, typo there. Let's do this again. Wait for seconds. Let's do this one more time. And let's have a longer delay here. So this is going to spawn something, wait 0.5 seconds, spawn something, wait 0.5 seconds, spawn something, and then have a long delay before we loop this around and have it spawn again. So disregard the loop for a second. We'll add that in. But basically what this does is when this method hits a yield statement, it is returning an Enumerator, which Unity under the hood is watching to see when 0.5 seconds has elapsed. So even though this code looks like it is synchronous, where this would cause the whole application to lock up, like if you put your thread to sleep for 0.5 seconds, this is actually asynchronous. So we're basically yielding an instruction to Unity to say, wait 0.5 seconds before running the next bit of this. So it's going to run until it hits the first yield, then it's going to wait 0.5 seconds, run until it hits the next yield, wait 0.5 seconds, run until it hits the next yield, wait 2 seconds. So to start this coroutine, we just pass in the name of the method to the start coroutine from Unity. So we can get rid of the spawn here. Let's make sure that this is working before we make it repeat infinitely. So we should see 3 saws spawn in here. So 1, 2, 3, good. And now to just make this loop infinitely, we flip back to our script and we wrap this in a while true. So now after it waits 2 seconds at the bottom here, it's starting back at the top and running through this chain again. So that should give us something that has kind of a pattern to it. So So we've kind of created a trap that if I now move the player over, there's like a space of 2 seconds for the player to sneak by before the saws fall down. And I'm not going to go into the logic of making sure that the player dies and the level restarts when you hit one of these. I'll leave that up to you since we've done that type of thing before. But this gives you much more control over pattern and spawning things. Like if you wanted to have a difficulty curve where your spawners became progressively more difficult over time, you could use Enumerators and coroutines to do that. The last thing that I'll show you is that when the prefab, or when this trap spawner is destroyed, all the coroutines that are spawned by it are also destroyed. But sometimes you need the ability to stop a coroutine yourself. And so that's one way. This is one way that we can start a coroutine. The other way that we can start it is like this. So we can invoke perform spawning and get an Enumerator back from it, which is what this is returning. Then we can call start coroutine and pass in that Enumerator. And then at some point in the future, we could call stop coroutine, stop coroutine, and pass in that enumerator. So imagine, like a bunch of stuff happens and then later on we want to stop the coroutine. We can invoke it this way. You can also stop all coroutines. If you have a bunch running on this script and you want to stop them all, you could call stop all coroutines. So I'm going to leave this commented out and go back to this way. But that's it for coroutines and how to use them. I'll make sure that there's a link in the description on Canvas that explains this in a little bit more detail and has some links to the Unity documentation, but this should be enough to get you started. The one thing that I didn't do here in our scene is hook up the windscreen. Let's do that while we're at it. So I have this UI here that displays the score. We can actually just use our score display script here, hook it up to our text, and let's go to level 1. And our score manager should follow us from this scene through our trap and onto the last scene where we get our final score. So that is all I have for you for this demo. Just to review really quickly, we created multiple scenes. We figured that it was really useful to have these prefabs for basically everything that we wanted across our scenes, which meant that, we could have the player prefab here, this 2D rig, and we could configure the player by editing the prefab, and that applies to all the players across every scene. So that was our scene setup, and then we learned how to create this score manager that sticks around by using don't destroy on load. We added the Singleton pattern to make sure that there was only ever one score manager across all of our scenes, and this is a pattern that you want to use sparingly, but is useful for our class to be able to take information across multiple scenes as you're working on your final project. So go forth, bring this into your final project, and I will see you next week.